everybody, and welcome to my notes. You are welcome to try to find this on Khan Academy or some other website if you prefer their videos. But for those of you who only want the information necessary for exactly what we're doing in our lesson, this one might be a little shorter. So this is Chapter 12, Section 2 of your book, and it's about arithmetic sequences. I know it looks like arithmetic, but we've changed the part of speech, so we're going to say it arithmetic. An arithmetic sequence is just a sequence that has the same number added every time. That number could be a positive, like in the first example, which is 2, 7, 12, 17, 22. So the number that's been added each time is 5. The second example has 3, 1, -1, -3, -5. You might notice those are going down. So that means the number we added each time was -2. There is a quick formula you can do to find that out, and it should remind you of the slope formula. So if for some reason you need to figure it out because it's not obvious to you, you choose what you want to, just pick 2 points, just like we do with slope. For this first one, let's say the 7 and the 2. I write 7 minus 2. On the bottom, I tell which position each one was in. 7 was the second number in the sequence, and 2 was the first number in the sequence. And that's 5/1, and 5 was my common difference. So it's a lot like the slope formula. You just pick 2 of the numbers that are in the sequence and subtract them over the top. On the bottom, the position each one was in. 7 is the second position, 2 is in the first position. The subtraction is just part of the formula, and that gives me the common difference. So just in case the common difference was some decimal that you didn't easily recognize, or you somehow just didn't see the number, there's the little formula that can help you with it. Most of the time we don't need it. So an arithmetic sequence is one kind of sequence. There's plenty of others. All we're going to do with this and with the next kind, geometric sequences, is answer a couple of questions. Is it arithmetic? You can check that by looking for a common difference. We're going to find the nth term of a sequence. We're going to find the sum of the terms of the sequence. And we're going to try to write the formula. So, if we want to answer the question, what is the common difference? It's just the number that was added each time, or the negative number that was added each time. We don't really talk about subtraction because we want to make sure we put the negative on there. So we say we added -2. That number is the common difference, and in each equation it's going to be represented by the number d, which is pretty easy to remember because, again, we're not creative as mathematicians and we use d for difference. We've got 2 versions of the formula for an arithmetic sequence. The first one is recursive, and we're going to save it for later. You may remember that's the one where we define the sequence, the numbers in it, by the one that came before. So that first version says a sub n, that's the nth term, is the term that came before plus the common difference, which makes a lot of sense. That's the recursive version. The second version, which we're actually going to deal with first, says a sub n, the nth term, is the first term plus n minus 1 times d, the common difference. That's the one we're going to use the most because for most purposes that's the easier one, because in the recursive version we have to have 2 numbers in a row, and sometimes we don't have that. So we're going to use that formula first to generate a sequence. So remember that we just plug in a 1, a 2, a 3 each at one time. So if I give you the formula a sub n equals 4 plus n minus 1 times 6, I can see the 4 is in the spot that belongs to the first term and the 6 is in the common difference spot. So you really could just write the 4 and then add 6 each time. Or you could plug in a 1 and you would get 4 plus 0 times 6, which is 4. Plug in a 2, you would get 4 plus 1 times 6, which gives us the 10, and so on. So you can plug 1, 2, 3, 4, and so on into the equation. Or kind of like slope-intercept formula, you can just find the spot that tells you where to start and how far up to go each time. We should also be able to go the other way. So if I give you the sequence, 6, 11, 16, 21, I can put the 6 in the spot where the first term goes. I can see that it goes up by 5 each time. So 5 goes in the common difference spot. So my nth term would be 6 plus n minus 1 times 5. Just following that formula that we were originally given, that a sub n is equal to a sub 1, the first term, plus n minus 1 times d, the common difference. I should note that in your textbook, they do not write it as a sub 1. They write just an a, and I feel like that's a little bit unclear, so I prefer to write it with the subscript of 1 so we can be sure we know that that's the first term of the sequence. We can also use the same formula to skip ahead. If I want to know the 10th term without going to the trouble of finding the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, and 9th terms, I can skip right to it. So if I want the 10th term of the sequence 7, 5, 3, 1, etc., I put a sub 10 for the 10th term equals, and then again, 7 is in the spot for the first term. 9 came from 10 minus 1. So I take my n minus 1, and in this case my n was 10, the 10th term, times the common difference. It's negative 2 that's added each time. So then I just work that out, and I find that the 10th term of that sequence would be negative 11. Yes, you can just work your way all the way to it, but occasionally they give you something crazy like the 50th term. You can still work your way up to it by finding each term in between. It just takes a really long time. So using that formula is a little bit of a time saver. So we take that second version and we can use it to write the sequence if they give us the formula, to write the formula if they give us the sequence, or to skip all the way up to one term if we want to just find the 10th or 20th or 30th term. The other formula we need to talk about is the sum formula. This is a really handy one too. It tells us the sum of the first n terms. It's a pretty simple one. You can see it says s sub n, s for sum, and n for the nth term. Then we have a sub 1, which again the book just calls a, plus a sub n. So when we do this formula, we're able to find the sum of the first 20 terms without actually figuring out what they all are. Yes, you could still write down the first 20 terms and add them all up. That's a legitimate method. It can just be a time-consuming method. So if we want to save time and we're given a sequence like 20, 17, 14, 11, and we don't want to find them all, the sum of the first 12 terms would be s sub 12 for 12 terms. So I put 12 over 2 in place of the n. And then I have the first term, 20, plus the nth term. Well, in this case, the nth term would be the 12th term, but we don't know the 12th term, and we have some choices here. To fill in this blank where it says, question mark, what is the nth term, we can either work them all out. I can keep subtracting 3 every time, which is my common difference. I could keep subtracting 3 every time until I get to the 12th term, or I could go back up to that formula we used earlier and I can figure out the 12th term. My 12th term would be 20, that's the first bit, plus 11 minus 1, I want the 12th term, so I subtract, it should be 12 minus 1, and I get 11 times negative 3. So 20 plus negative 33, I've done my calculations wrong, which I've just realized, 20 plus negative 33 would give me negative 13. So that tells me that the 12th term is negative 13, which I have somehow calculated as negative 10. All right, so now I take that negative 13 and I can fill in this question mark. Once I know a sub n, which if we're asking for the 12th term, a sub n is the 12th term. I figured out the 12th term with my other formula, and I can stick it in here now and cross out my miscalculations. And then I can say 6 times 20 plus negative 13 is 7. And I'm done. So the sum of the first 12 terms would be 42. Is that faster than finding all 12 and adding them up? Possibly not in this case, but if you were asked for the sum of the first 50 terms or the first 100, it would definitely be faster to use those two formulas in combination. So remember, you're going to be able to get straight from the list. They're going to tell you you're in. So you're going to be able to just plug that in. Your a sub 1 is just the first term. You can get it by looking at the list. A sub n is a little trickier. We have to go back up to our formula to get our a sub n. So we got to plug something into a formula, get an answer, and stick it back in here. A little extra work, but it can be faster than just finding all the terms and adding them up. The last thing we need to be able to use is that recursive formula. When do we use the recursive formula? Well, if we remember what it looked like, you might notice that it has less. We don't need to know a sub 1 in order to get this formula. We don't have to have the first term, which is kind of great if we aren't given the first term. If they give us a question in this format, the 8th term is 8 and the 20th term is 44. Well, now we know two of the terms, but neither of them is the first term. So the first thing I need to do is find my common difference. I use that formula we talked about at the very beginning. The 8th term is 8, so the term goes here, and its position here. So the 8 is the 8th term. The 20th term is 44. So 44 is the term, and the 20 is its position. So just like the slope formula, I put the actual term, the position on the bottom. And then basically the difference between the two terms was 36, and it had to be split up into 12 little chunks because there were 12 numbers between. So my common difference is 3. Negative 36 divided by negative 12 is 3. There's my common difference. And if I go to that recursive formula, that's all I need right here is the 3 from my common difference. I don't have to know the first term to use the common difference formula, which makes it great. So if I wanted to know the 4th term, however, to use this, I would have to figure out the 3rd term. It says this plus the term that came before. So this is not our most useful formula, and we don't use it unless we kind of have to, such as in this situation. If I wanted to know the first term, given only this information, only that the 8th term is 8 and the 20th term is 44, I kind of have to go back to that other formula and plug in what I know. I know, and I could use either one. I've chosen that the 8th term is 8 to be the information I'm going to go ahead and use. But you could have used the fact that the 20th term is 44. Again, this should really remind you of that slope-intercept formula. So I'm going to go here. We were told that the 8th term is equal to 8. So the a sub 8 is 8. The first term is what we're trying to find. The 7 is here because it came straight from 8 minus 1. Remember, this is our n minus 1. And we know the common difference is 3 because I found it up here. So first term is what I want to find. 7 came from 1 less than 8. And the 3 is the common difference. I plug those in and solve for a sub 1, and I can find out that the first term was 13. So if I prefer this version of the formula to the recursive version, and a lot of people do, if you prefer this version, then you would put first term, we calculated to be 13, plus n minus 1 times the common difference. So this is the other version of the formula. Here's what it is with the recursive version of the formula. You can see that this one is more useful because we can go straight to the nth term. With this version, in order to find the 10th term, I have to know the 9th term. And in order to find the 9th term, I have to know the 8th term. And in order to find the 8th term, I have to find the 7th one. So you have to find them all, making this one a little less useful, but a little easier to find because it only requires the common difference and doesn't require the first term. Easier to find, harder to use. So the questions you need to be able to answer for your assignment are, is it an arithmetic sequence? So you just see, is the same thing added every time? If we have multiplied by something or squared, then it is not arithmetic. It's still a sequence, possibly, but not arithmetic. We need to be able to write the formula, whether it's a recursive formula or a regular formula, and we need to be able to find the common difference. Your assignment is listed in the description, and if you have any questions, please feel free to send me an email or to start a discussion on your Google Classroom.